cooling sheet. Let's continue now. Now let's talk about the true elephant in the room. Like I know most of you are happy about the upcoming iPhone 7, which I am as well. I'm very happy and also waiting to have my hands on one of those gadgets. But that elephant in the room, I'm talking about thermodynamics. To achieve this level of thickness, Apple has completely stripped away the multi-layered copper vapor cooling chambers that modern flagship phones rely on to spread out heat. Instead, the leaks reveal that Apple is relying entirely on a single ultra-thin graphite sheet to move heat away from the core silicon. But there is a massive hardware conflict. This device is built around an incredibly powerful A19 Pro processor engineered to run a heavy localized Apple Intelligence AI loop constantly in the background. Running complex neural processing models generate extreme continuous current draw, and the high processing load that A19 processing chip is going to pump out intense heat density with zero physical air gaps and no copper vapor chamber to pull that heat away. The graphite sheet will instantly saturate. That heat has nowhere to go except right back into the motherboard component. Now, the next thing we are going to look at as a technician standpoint, right, is microcapacitor cooking and power rail degradation. That is what I'm seeing now from this point. That is a technician standpoint, not your regular reviewer standpoint, but as a technician standpoint, that is what I'm seeing here. Let's look under a microscope. Now you get to understand things well. Now let's look under the microscope at what's happening to power rails when thermal saturation hit 90 degrees Celsius. The spacing between the main power management chip and the central filtering capacitors has been compacted by nearly 30% to save space. When heat builds up in this dense pocket, it slowly cooks the surrounding microcapacitors over months of daily use. Continuous thermal stress dries out the internal dielectric materials inside these surface mount capacitors. Once a capacitor dielectric degrades, its capacitance drops, causing voltage ripples across VCC main power lines. Eventually, the capacitor fails entirely and shuts out to ground, instantly breaking a $1,200 logic board over a simple thermal design flaw. You get it now? So it wasn't that I just cooked in some point to make some some technical decision. Is what we deals with daily in the technical shop. When a board faces a lot of thermal heat, they dries up and then they get some tiny cracks under them, which cause voltage ripples. Board end up shorting to ground. That means your board is in need of a technician. Now let's talk about one thing most people focus on when choosing a new gadget. Now let's talk about the battery and the acceleration swelling. But the component that is going to take the absolute worst beating inside the iPhone 17 Slim is the battery. No doubt about that. The component that's going to suffer most inside the iPhone Slim is the battery. I can assure you of that. The phone has not been released yet, but from a technical standpoint, I can assure you of that. The battery is going to suffer the most of the pain. To fit the razor thin frame, Apple is utilizing a highly compressed, low-profile lithium point cell. Lithium-ion batteries chemistry absolute heat ambient heat above 45 degrees Celsius. I'm telling you that as a practical engineer of lithium batteries, because the logic board is packed tightly against the battery wall with no physical insulation layer, the continuous heat from the AI processor will break the battery cells day in and day out. This will cause the battery health to drop from 100% to 80% in less than 12 months. Worse yet, continuous high temperature exposure accelerates the internal gas accumulation inside the lithium layers, leading to severe battery swelling. A swelling battery inside will push direct against the back of the delicate OLED display, cracking the screen assembly from the inside out. We face a lot of problems like that in a repair shop. Most of the time you receive from and then you find out that the battery has swelled and the screen is being pushed up, forcing the screen to sometimes crack or break, needing a new screen replacement, which is not a user's fault, but is a design, a design fault or a design flaw. Now I'm sure you are asking, what is Majesty Computers or Majesty repellability verdict on the Apple iPhone Slim? What is the master technician final repellability verdict on the upcoming iPhone Slim? From a micro-engineering perspective, it is a stunning piece of manufacturing, fitting a flagship processor and a split motherboard into a razor-thin chassis. It's impressive. Apple, you did impressive with that. I give you a thumbs up for that design. I'm just waiting to see how it is going to turn up, which is an impressive design. And I'll be very happy if you support by clicking that like button, joining by subscribing, and also dropping your comment below, letting us know what you think about Majesty Computer. Just a comment below. Will you trade your cooling system just to have a tiny phone in your hand? Majesty Architect, and the workbench is officially clearing up.